Hello, welcome. This is AP Chemistry Unit 1, Topic 3, Pre-Test Assessment. So I'm making this small quiz so that you know where you are before you start the lesson. This assessment covers the Unit 1, Topic 3, Elemental Composition of Pure Substances. You have 15 minutes to complete 10 questions. This is the AP Learning Objectives covered. You can explain the quantitative relationship between the elemental composition by mass and the empirical formula. And you can explain the quantitative relationship between a pure substance identity and its molar mass. Let's have a look if you can make the molar mass calculations, and we'll start the test. In this test, which is very easy, you will need to answer question 1, what is the relative formula mass of water? So if you want to do this, you have just to add the atomic masses of the hydrogen and the oxygen, and every one you have to know the number of atoms. So you have 2 hydrogen atoms and 1 oxygen atom per mole. That's why you have to multiply the hydrogen by 2 and the oxygen by 1. Once you get the result, you can press it. So it's almost 18.02 here. We'll get the answers at the end only. You need to do this also for carbon dioxide. If I remember, it's 44.1. And then you can do this for everything. This is percentage of sodium chloride and sodium by mass. So in order to do this one, you have to get the mass of sodium and then divide it by the mass of the total thing. So check in the periodic table what is the mass of the sodium, and then what is the mass of the sodium plus the chlorine, and then after that you multiply the result by 100. If you are able to do that, then you have already know what is the percentage mass. If not, don't worry, because we are explaining this in the lessons after a while. Very good way. Now let's have a look at the next questions. You have to answer everything so you can get your number. What is the molar mass of calcium carbonate? Again, I need to add the calcium mass in addition to the carbon mass in addition to 3 of the oxygens, and you will get your answer. I'll just pick anything here. Which element has an atomic mass close to 14? The carbon, I think, is almost to 12, and nitrogen is 14. And what is the molar mass of the ammonia? You have to answer this carefully because you will get to know at the end what is your answer. What is the percentage of water? H2O is hydrogen by mass. You need to know what is hydrogen. So again, you will look at hydrogen and you will look at H2O mass. And as I'm telling you, I'm answering this very fast because this is a quiz that you have to do. If you are not able to do, don't worry, because actually this lesson is designed so that you can find at the end if you know things or not, and then explains to you how many hydrogen atoms are in the calcium hydroxide. This calcium hydroxide has OH2. You must know that the number of atoms can be found by multiplying 3 numbers. The first number is the coefficient. Coefficient is the number that you find before the molecule structure or the formula structure, and the other atom is the atom after it. There is a 1 here but it's hiding, and then there is 2. So multiply this 1 by 2, you get 2 atoms of hydrogen, and we can easily pick this one. So let's see how much we will get. What is the molar mass of C6H12? So I have to get C, but which is almost 12 multiplied by 6, and hydrogen, which is 1 multiplied by 12, and oxygen, which is 16 multiplied by 6, and add all this together and find the answer. I don't have the answer now, so I'll just pick anything to finish the quiz. And there is one question which was not answered, this one. That's why we'll answer it, and then we'll see our result. When we submit the test, we see that we got 80%. That's very good, considering that we were using numbers randomly. And then you will get to know what is the points that you need to understand. You have excellent foundational knowledge, but then we can press here start learning journey, and then we'll see our question explained by explaining the lesson itself. So let's start the lesson now. Okay, let's move to the lesson itself. Let's open our study timer. So starting and see. Understanding the molar mass. What is the molar mass? Basically, the molar mass is the mass of 1 mole of substance measured in gram per mole. It's calculated by adding up the atomic masses of all atoms in a chemical formula. So I have water, for example. Step 1, identify the atoms. So I have 2 hydrogens and 1 oxygen. Find the atomic masses in the periodic table. So the hydrogen is 1.01, oxygen is 16. Step 3, calculate. So I have 2 of the hydrogens, every one of them is 1.01, plus 1 of the oxygen, which is 16. So the total is 2.02 plus 16 equal to 18.02. So calculate the molar mass of carbon dioxide. How can I do this? Yes, 1 carbon and 2 oxygens, 1 multiplied by 12.01 plus 2 multiplied by 16. Don't round the numbers that you get from the periodic table. It's equal to 44.01 gram per mole. What is the percentage mass composition? Percentage mass. The percentage composition is the percentage by mass of each element in a compound. It tells us what fraction of the total mass comes from each element. So if the element is made from if the compound is made from 4 elements and I have one of them only, this is 25%. It's 25%. If the mass of the element is 50% from the total thing, so if the total thing is 2 grams and this is 1, so it is 1 over 2 multiplied 100 is equal to 50%. Example, for molar mass of water is equal to H.02. The mass of hydrogen inside that is 1.1 multiplied by 2. Take care. Some students will tell me that the hydrogen is 1.01, but you don't have one hydrogen, you have two hydrogens. So you have to get it all. Take care. You have to get it all. The two hydrogens, not one of them. So it's equal to 2.02 and divided by the total mass. 2.02 divided the total mass, 18.02, multiplied by 100 is 11.2. So the hydrogen inside the water molecule represents what? Represents 11.2%. Let's mark everything that we are done. Okay, and then understanding the subscripts and brackets. Take care. H2SO4, how many hydrogens you have? H2SO4. So how many atoms you have from each? Let's start to try to understand how we will know the atoms of each. H2SO4, you have how many hydrogens? I have 2 hydrogen atoms. How many sulfur? I have 1 sulfur atom. How did you know it's 1 sulfur? Because there is 1 here, but it is hiding after the sulfur. And how many oxygens there are? For 4 oxygens. It's very important to know how to count the atoms, otherwise your calculation for the molar mass will not be correct. Now I have calcium hydroxide, Ca. This is one element, calcium. Oxygen is one element and hydrogen is a separate element. That's why both of them is written in capital. This is not a separate element. That's why the second letter here is in small letters. And then 2. How many calciums I have? I have 1 calcium. I have 1 oxygen, but this 1 is multiplied by 2, so the total is 2 oxygens. And I have 1 hydrogen, but this is multiplied by the number in the bracket outside, so I have 2. This means that I have OH2 means I have 2 H's like that. So OH2 actually means I have 2 OH's like that. Aluminum sulfate. So aluminum, I have 2 atoms. The subscript or the number after the atom tells me that it is 2. And then there is SO4. Remember that we multiplied every number by the number in the bracket outside. So there is 1 sulfur here, but it is multiplied by 3. So the sulfur is 3. Oxygen is 4, but multiplied by 3, so it is 12. So I have 2 aluminum. I have 3 sulfur, and I have 3 sulfur, and I have 12 oxygen atoms. Now let's bookmark this one. We are done with all the bookmarks. So I am done with this, and I am done with this. Sorry, I restarted the video, so the bookmarks earlier were removed, and then this one was bookmarked. So everything was bookmarked in the basic level. Is this all done? So they are all bookmarked here. Now we can move to the next level. Remember that always you can find here the help guide, the atomic masses that you might need, and the formula sheet that you might need also. Everything is here. So this is the essential formulas that you need. This is not on in this lesson, but in all lessons like that. Atomic masses, and this is the help guide that will tell you to understand everything. So let's see the next one. The next one is the next intermediate level. So if you have complex molecular formulas working with hydrates, for example, and complex compounds, so copper 2 sulfate pentahydrate, for example, this means that it is CuSO4. Take care, the U is small because this is the second letter. Very important to be careful about small and big letters in the exam. So 5H2O. So compound is made from 2 parts, the salt itself and the hydrated part or the water itself. So copper sulfate, copper is 63.535 from the periodic table. I have 1 sulfur here. Remember, after copper there is 1 and 1 sulfur. So sulfur is 32.07, and I have 4 oxygens. Every oxygen of them is 16. So that's equal to 159.62. Remember, this is only the copper sulfate part, but still there is water. I have 5 multiplied by the water. Water is 12.01 plus So 16.01, which is the 16.00, which is the oxygen, and 2 from the 1.00, 1.01. So it is total as 18.02. If you add this 5 times, why it's 5 times? Because there is 5 water molecules here, you will get 90. So you need to add this part, which is the water part, the water part, which is 90, together with the salt part, which will make in green. This is the salt part, which is 159.62, and then add them total. You will get finally the mass, which is 249.72. Now let's do some practice. We calculate the molar mass of aluminum sulfate in the same way. So I have aluminum sulfate. So we'll do the same thing. I have 2 aluminums. I have 3 sulfurs and 12 oxygens. Remember how we calculated the atoms of each. And then calcium carbonate. Also try to do it and see if your answer is correct here. So we bookmarked this part, already done. And then the next part is the multi-step percentage calculation. So if 50 grams of calcium carbonate contain what mass of oxygen? I need to find the percentage of oxygen in calcium carbonate. So calcium carbonate, the total mass of it is equal to what? 100.09. How did you do that? We calculated the same way. So we have added the calcium together with 1 carbon and 3 oxygens. Then the total is 100.09, and then I added 3 of oxygens to get it 48. Then you divide the mass of the oxygen. Remember, not for 1 oxygen, for 3 oxygens. So that's equal to 48, and divide this by the total mass of the compound. So 48 divided by 100.09, and because this is percentage, I need to multiply it by 100. So multiplied by 100%, you will get 47.96%. The step 4 is find the mass of oxygen as a result. That's equal to 23.98. So again, I have a 50 gram of the calcium carbonate. So the first 3 steps, you found the percentage mass generally. So you found the percentage mass generally in a calcium carbonate compound. Take care, this is a complex compound, means it has 2 steps or more. So I get 47.96. This is the percent of oxygen in any calcium carbonate. In my example here, the calcium carbonate was 50 grams. So I need to find what is 50 grams multiplied by this percentage, 47.96 over 100. So I get the percent from this 50 gram. If my answer was 25, if my question was 25, so I will do 25 multiplied by 47.96 over 100, and so on. Make sure that you understand this very well. And after doing it, you can bookmark it as well. Always check up your percentage to add up to 100%. So if you have 2 numbers, you are asked to find the mass of oxygen, then what is the mass of calcium, then what is the mass of carbon. We found that this is 47.96. We should find these two also by dividing their masses, divided by the total mass. The total masses should be 100%. Same if I told you I have a piece of bread and you are cutting it into 4. If this is 25 and 25 and this part big one is 50, what is the total? The total is 100%. Same for the percentage, they all should come to 100% to make sure that you are working correctly. Now we'll study what are the empirical formula basics after a little sip of water. Try to find together what's the empirical formula. The empirical formula simply is the simplest whole number ratio. So if I have a compound which is a little bit big, C6H12O6, if I want to simplify this molecule, I will make it a CH2O. How do I do this? Check the numbers. I have 6, I have 12, I have 6. What is the smallest number of these all? Is it 6 or 12? It's of course 6. Then I have to divide all these numbers by the smallest number. So 6 is divided by 6 is 1. 12 divided by 6 is 2. And then 6 divided by 6 is 1 again. So again, I have carbon and hydrogen and oxygen. There is 6 atoms of carbon, 12 atoms of hydrogen, and 6 of oxygen. Divide them by the smallest number. What is the smallest number? It is 6. So divided by 6, divided by 6, divided by 6. Divide all by 6. 6 divided by 6 is 1. So I have one carbon only. 12 divided by 6 is 2, so I have two hydrogens, and 6 divided by 6 is 1 again. So you have C and H2 and O. I don't write the 1 for sure. C2H6, what is the smallest number? It's 3. So divide by 3, by 2. Divide by 2. So this is 2 divided by 2 is 1, so I have one atom here, and 6 divided by 2 is 3, so I have 3 atoms here. H2O2, the number is 2, 2 divided by 2 is 1, 2 divided by 2 is 1, and 2 divided by 2 is 1 again, so I have one atom and one atom, so it is hydrogen 1 and oxygen 1. So let's bookmark this as well. This is the simplest formula, or what I know as the empirical formula. This is all what we have done until now, today. Let's go for the advanced level, how to form from the percentage composition to empirical formula. This is also important and need to break for 30 seconds so I can freshen this up. It's very important to understand this. So the first step is to assume that you have 100 grams, because usually in some easy examples, I will have 40 gram, 6.7 gram, and 53.3 grams. But since I don't have grams, I have percentage here by mass, so I can just change them from percentage by mass into grams. How do I do that? 100 gram assume. I will tell you, if you have this 100%, and you have three ratios, 25%, 25%, and 50%, and you need to change this into grams. Just imagine that the whole thing is 100 grams. So if the whole thing 100 grams, what will be the ratios? It will be 25 gram to 25 gram to 50 grams to 50 grams. So this is what I meant. This is what I meant to 50 grams. This is what I meant when I said change the percentages into mass. Here I change it 25% into 25 grams, 25%, 25 grams, 50% into 50 grams. So this will be 40 grams, 6.7 grams, 53.3 grams. If you want to know the empirical formula, you need to know how many moles are there in every mole of the moles of atoms. Like if I have, for example, the compound, and I need to find what is H2O. The H2O, for example, have two hydrogens in every mole, 2 moles of hydrogens in every mole of the molecule, and 1 mole of oxygen in every mole of the molecule. So then you will do the same. I need to find the number of moles. How do you find the number of moles? Number of moles is equal to mass over molar mass. So the mass of the substance divided by its molar mass will get you its number of moles. Why do you need to get the number of moles? Because you need to know the ratio between this one to this one. If it is 2 to 1, so I have 2 hydrogens for every 1 oxygen. The same like that. No, my example is not water. It is something else. I'm just using water to explain. So I have carbon here, the number of moles. What the mass is 40 grams divided by its molar mass. What is the molar mass of water? Is 12. So 40 by 12 is equal to 3.33. Now I need to find 6.7 for hydrogen divided by its mass. It's 1.01, and oxygen is 13. So 53.3 divided by 13 by 16. Or let's do it like that. I like to do it like that. This is the mass, 40 grams, 6.7 grams, and 53.3 grams. Divide everyone by its molar mass. So this is divided by 12.01. This is divided by 1.01, and the molar mass of oxygen is 16. So what are the results that you got? I got in the first one 3.33 moles. I got here 6.63 moles, and I got here 3.33 moles. So I need to find this as whole number ratios. So how to get the whole number ratios? Divide all of them by the smallest again. Divide by smallest. When you are dividing by the smallest, you are getting a ratio by whole number. So 3.33 divided by 3.33, 6.63 divided by 3.33, and 3.33 divided by 3.33, you will get a ratio of, what is the ratio? 1 to 2 to 1. You get all of them divided by 3.33. You get 1 to 2 to 1. This is the ratio. The numbers has to be whole numbers. I cannot put like that. I cannot say 1.9, 1.8, 2.1. It has to be whole number. So the ratio of carbon is 1 to 2 hydrogens to 1 oxygen. Remember, I always don't write the hydrogen. I'm writing it for here so you can understand it. But this is the simplest formula of my compound using the masses. So try to do this for potassium, manganese, and oxygen and find the empirical formula the same way we found it. And then we'll see the last part, which is molecular formula from the empirical formula and how we can do it. Let's try again to explain very slowly what is the empirical formula. The empirical formula is simply the whole number ratio. So let me try to make this closer to you. There is a number which is like n. This number is the difference between my empirical formula, the simplest form, and how many times it is repeated. So if this number is equal to, means that I am having my empirical formula repeated 2 times. If it is repeated 3 times, my compound will be C3H3. If it is repeated 4 times, it will be, so if it is repeated 3 times, 4 times it is C4H4. So the number which the empirical formula times is repeated is the empirical formula. So CH can be 2 times, 3 times, 4 times, or whatever, and this makes different number of molecular formulas. And this is the empirical formula. So this is the relationship between the empirical and the molecular, how many times the empirical was repeated. I can find also the masses. The masses is also related with the same multiplication. So if the mass of this one is 12 plus 2 is equal to 14, how much will be the mass of C2H4? It's going to be 28. So here, sorry, it is 13 because one hydrogen only. So this is 13, and this will be 26. Why? Since the number of atoms is repeated 2 times, the mass also will be repeated 2 times. If 1 mole of CH is 13 grams, 1 mole of C2H2 will be 13 multiplied by 2. What about this one? 13 multiplied by 3. 13 multiplied by 4. So let's do 13 multiplied by 3. This means that the mass of C3H3 will be equivalent to, this is 13 multiplied by 3. So this means the mass of C3H3 will be 39. And if we said 13 multiplied by 4, this means that the mass is 52. So not only the count of atoms is repeated 2 or 3 or 4 times, its mass also will be related. This is very important to answer the questions of the molecular mass. So as per the steps here, the universal method for finding empirical formula, convert all data to moles. How do I convert it into moles? By dividing the number of moles is equal to the mass over the molar mass. Find the smallest number of moles and divide all the moles by the smallest number. Same we did there last time, CHO for example. Find if I have 6 moles, 3 moles, and 3 moles. So I divide all the numbers by the smallest, which is 3. How did I get it? From mass over molar mass. 6 divided by 3 is 2, 1, 1. So my ratio is C2H0. So if needed, you multiply to get whole numbers. Sometimes I get the ratio like that, 1.5, 1.5, and 1. This is not a whole number. I cannot use it. I cannot say C1.5, H1.5O oxygen. So I need to multiply it by a certain number. I choose whatever number that I can use so that I get whole numbers. 1.5 multiplied by 2 is 3, 3, and then 2. This means that my ratio will be CH3O. This is working, but the decimals, I can never use this. In these questions, you will get simply how to find the mass into empirical formula, or if you have it as percentage like we explained how you will change it. And what if I don't get whole numbers? I said again I have to multiply. So if I get 0.5, I'll multiply it by 2. If I get 0.33 or 0.67, I multiply it by 3. If I get 0.25 or 0.75, I multiply it by 4. Now, what is the relation between empirical and molecular? We have explained very well. So CH2O and C6H12O6, this is the empirical formulas and the molecular formula. So this is basically repeated 6 times. Also the mass, 30.03, if you multiply it by 6, it will be 180.18. So if you want to know how many times the empirical formula is repeated, if I want that this empirical formula is CH2O, and I need to find the molecular. In order to find the molecular, you cannot find it if I don't tell you how many times you are multiplied. Take care, this is very important part. Focus with me. I can easily divide the number of the molecular and change it into empirical. right? So when I told you C6H12O6, you just divided everything by the biggest number and you got CH2O. But if I told you to do the opposite, you will not be able to do it. Why? Because you don't know how many times the empirical is repeated. If I told you it is CH2, CHO, is it repeated one time? Is it repeated two times? Is it repeated three times? Because every one of them gives a different result. So this one gives CH2, CHO, C2H2O2. Take care. Sometimes the empirical and molecular might be the same. Huh? Let's stop here. If I told you CH4, what is the empirical? It's still CH4 because you divided everything by 1. The smallest number is 1. So 1 divided by 1 is 1, and 4 divided by 1 is 4. Don't write 1 in the exam. I'm just explaining to you. If this is repeated twice, it is like that. If this is repeated 3 times, it is like that. So you can change all of this to the same empirical formula without I'm telling you anything. You'll just divide by the small number because the empirical for all of this is the same. The empirical of this one is this one. The empirical of this one is CHO. The empirical of this one is still CHO. But in order to change it from empirical into molecular, you cannot do this alone. You have to multiply by a certain number. I have to tell you what is this number. How to get this number in, how to get the number it is repeated, you can divide the mass of the molecular by the mass of the empirical. If you divide the molecular mass of the molecular, the big compound, by the mass of the simplest ratio, which is the empirical, you will get an n. What is the n? It's how many times it was repeated. It is how many times it was repeated. So you'll be able to know how many times it is repeated, and you will know what is your molecular formula. If I told you that the mass changed from 180 to 3, you will know that I divided by 6. If I told you it changed from 28 to 14, you will know that it was repeated twice. If I told you it changed from 34 to 2, you will know it is repeated twice. So if I give you the empirical, you can know the molecular, right? If I told you that this is CH2O repeated 6 times, you will tell me the molecular is C12H, so C6H12O6 and so on. Don't forget to see the next video also because it will contain a lot of practice. I know that most of the students, even after explaining very well, they don't answer very well unless you finish all the worksheet. Once you are done with the whole worksheet, you will be very good. If you want to know how to get the molecular formula from the empirical, let me tell you again. I have a compound. You have to find the step 1, which is calculating the empirical formula mass, and then step 2, find the multiplier, find how many times it's repeated. So when I found the formula CH2O, I found that its mass, this is the empirical, its mass is equal to 30.03, while he told me that the molecular is so and so. If he told me that the molecular is 90.09, so I know that the molecular compound is just a repetition of the empirical 3 times. So what is the molecular? Just repeat everything by 3. Why? Because you said the multiplier number is 3. We'll see also the complex stoichiometric relationship and more difficult questions in the practice video. Don't forget to see the practice video. Again, let's repeat. I will put the link here on how to find this quiz, how to use it online for free, and then you can see the help guide, the atomic masses. You can see how much time, if you started here at the beginning, you'll see how much time you have spent on these exercises, and then you will find everything explained here. Don't forget to see the practice. The practice is more important than just explanation.